So in our final section of Chapter 8, we're going to solve quadratic systems. We're going to review classifying conics, and then we're going to write conics in standard form. So when we think about quadratic systems, we're talking about systems, meaning sets of multiple equations. And when we're saying quadratic systems, then at least one of them is going to be quadratic. So you've already solved linear systems. We learned how to do that with substitution and combination. So combination is sometimes called elimination. So we're going to work with solving when you've got a mix of linear and quadratic equations, and also when you've got two quadratic equations to find the intersecting points of our graphs. So the type of problem that might be used to do this is using LORAN, which is a radio navigation system, to triangulate to find the ship's position. So you'll see that radio signals from stations A here and B and C help locate the position of this particular ship. And then they give us these equations. You can see that the equations for these look like they're hyperbolas. The minus sign here would be a good clue that that was the case. So we're going to go through and find, how do I find this intersecting point of my two hyperbolas? But first, let's talk about what they look like. Here's a linear quadratic system, so a line and some form of a quadratic function or a general second degree equation. And you see it's possible the line won't hit it, so I'd have no solution. It's possible I could have a tangent line, so I could have one solution. And it's possible I could hit in two places and have two solutions. So if we wanted to graph this, if I see x squared plus y squared equals 20, well, that's a circle. Okay, and I know that it's h and k are equal to 0. H is equal to 0. K is equal to 0. That means my center is at 0, 0. And I have a radius of 20. Okay, so that's going to be between 4 and 5. 1, 2, 3, 4, 5. So about there. 1, 2, 3, 4, about there. 1, 2, 3, 4, about there. And 1, 2, 3, 4, right about there. So if I wanted to go ahead and graph that guy, that looks about right. Okay, a little large. Still a little big. That's pretty close right there. Okay. So that gives you a generic idea of the graphing of the circle. And then y is equal to x minus 4. So I have a y-intercept of negative 4. 1, 2, 3, 4 right there. Pretty close. And I have a slope of 1. So from here I'd go up 1, right 1. And when you look at graphing that, it would go through like that. And I know I'm going to find two solutions. So I've got a solution here and a solution here. But it's difficult to tell what this solution is. And it's difficult to tell what that solution is. So what's complicated about solving by graphing is the same thing that was complicated about it when we were solving linear systems. Sometimes it's difficult to tell what the actual point is, and then you have to test. Okay, so if we worked with something like this, what I could do, and this will lead into how do I solve it using an equation, is I would substitute. I could take this, if y is equal to x minus 4, then I can substitute it into the other equation in place of y. And now I've only got one variable, so I'll have x squared plus, this is going to be x squared minus 8x plus 16 equals, 20. And I know I've got to combine like terms, and I want to make it all equal 0 because it's a quadratic function. So I'll have 2x squared minus 8x, and when I subtract 20 minus 4 equals 0. I can factor a 2 out of everything, so this would be 2 times x squared minus 4x minus 2 equals 0. And then I would want to solve this. Now I can see that factors of 2 that have a difference of 4, that doesn't exist. I'd have to use the quadratic formula, so I'd get some pretty odd solutions. So I'm not going to finish this out. Not that I can't finish it out, but it's going to take a long time and be a little awkward. Let's look at another example. If I wanted to solve this by substitution, I could solve for y squared and then substitute in here for y squared. So if I add y squared to either side, x squared minus 9 is equal to y squared, then I could plug that in place of y squared. So y squared was equal to x squared minus 9 plus 16x plus 39 is equal to 0. So now I couldn't have solved for x squared and plugged in, because then I still would have had an x in the equation. And remember, the goal is to get it down to where there's only one variable. So I've done that with x here. So I'll have x squared plus x squared is 2x squared. I'll have plus 16x, and I have minus 9 plus 30 is, plus 39 is 30. Again, I can factor a 2 out of this, so x squared plus 8x plus 15 is equal to 0. And if I factor this, factors of 15 that add up to be 8, that would be 3 and 5. So this is x plus 3 times x plus 5. And so when I solve this, x is equal to negative 3 and negative 5. So that means I'm likely to have two solutions because I have two x values, negative 3 and negative 5. So now I'm going to take negative 3 and I'm going to take negative 5 and I'm going to plug them back up into these equations. I think I'm going to plug them into this equation because it's simpler than the one above. So when I have negative 3 plugged in, I'll have 9 minus y squared minus 9 is equal to 0. So 9 minus 9, I'll get negative y squared is equal to 0. So y would be equal to 0. And when I plug in negative 5, I'll have 25 minus y squared minus 9 is equal to 0. 25 minus 9 is 16 is equal to y squared. So then y would be equal to plus or minus 4. Okay, so that means I've got yet another solution. I have a third solution. And when I plug in plus and minus 4, I'll have 4, and I'll have negative 5, negative 4. Okay, so in this particular case, the way my two quadratics interacted, I had 3 solutions. Okay, so go ahead and practice some of this work. Do problems 3, 9, and 10 from 8.7. And then come on back. So when you look at what we just went through, I probably had a situation like this one in terms of the 3 solutions. These are the different possibilities when you start getting a couple of different quadratic functions interacting. So you could have no solution with no intersection point. You could have 1, 2, 3, 4 different solutions. So if I want to go ahead and do a problem like this through elimination, the first thing I want to do is if I add these two together, I'll be able to get rid of the x and the y squared. So this will cancel out with that, and I'll get negative 4x minus 4y plus 4 equals 0. So I would want to go ahead and divide everything by 4. Right? So I'll have negative x minus y plus 4 equals 0. And then if I take and solve for y, I'll have negative x plus 4 is equal to y. Okay, so I have a new equation. And if I take this and I plug it back up into the original equation in place of y, negative x plus 4 in place of y, and this needed to be squared, minus 4x plus 2, now I've gotten rid of one of my variables. So when I first did the elimination, I wasn't able to get rid of both variables, but then I was able to use substitution to go ahead and get rid of the y. So I'll have x squared minus, and this is going to become x squared minus 8x plus 16 minus 4x plus 2 equals 0. And so I'll have x squared minus x squared plus 8x minus 16 minus 4x plus 2 equals 0. So this is just taking the parentheses off. The x squared gets rid of the x squared. I'll have 8x minus 4x, that's 4x. Now I'll get negative 16 plus 2, that's minus 14, equals 0. And so 4x is equal to 14, and x would be equal to 7/2. If I take the 7/2 and I plug it back in over here, I'll have negative 7/2 plus 4, which would be 8/2, equals y, so y would be equal to 1/2. So my solution here would be 7/2, 1/2. Okay, so we were able to use elimination to get rid of the squared terms, and then substitution to go back and get rid of what remained. So remember, we worked on this last section. I can use this discriminant to tell what type of conic it is. And the point of doing that is to be able to then take it and put it in standard form, which is going to involve some work. Okay, now I'll tell you, in fairness, this is nice. It's great to be able to do this, but I think if you simply start working at putting the item into standard form by doing the basics that you do to arrange a general second degree equation, you'll find out pretty quickly what it is, whether you use the discriminant or not. So I'm taking a look at this, and I'm going to start. What I want to do is I want to cluster my x's and my y's together, and I want to move my constant to the other side. So I have x squared minus 18x plus y. But now you may notice x is squared, but there's no y squared. This has to be a parabola. So I'm going to go ahead and I'm going to move the y to the other side. So I'll have negative 6y minus 99. And I did this because I need to have the square of a binomial on this side, and I'm going to complete the square. That's why I was practicing it a little bit ago. So I'm going to take 18, divide it by 2, that's 9, and I'm going to square it. So I'll have x squared minus 18x plus 9 squared. So now I've created a perfect square of a binomial on this side. This is x minus 9 squared, negative 6y minus 99 plus 81. So minus 99 plus 81 is going to be negative 18. All right, and if I want to finish putting this in the correct form, I have to get y as a binomial, so I need to get the coefficient off. I'm going to divide both of these guys by negative 6, so I'll have negative 6 times y plus 3. All right? So x minus 9 squared, negative 6 times y plus 3. So now I know that my center is at 9, negative 3. So here's 9, 1, 2, 3. It's going to be a little funky because I'm a little off here. I know that negative 6 is equal to 4p. So p would be equal to negative 6/4 or negative 2/3. I'm sorry, negative 3/2, not 2/3. So negative, right? X is squared, so I know this is a vertical quadratic. I'm going to move negative 3/2, so that's negative 1 and 1/2. There's my focus. So my focus would be at 9 and negative 3 minus 3/2. That's negative 4 and 1/2. Okay, there's my focus. I'm going to go up 1 and 1/2, and that's where my directrix will be. So my directrix will go through here. And again, I would go ahead and I would use an input-output table. What values would I pick? I'd probably pick 8 and 7 for x. Let's try 8 and 7. Well, 8 minus 9 is negative 1. Negative 1 squared is 1. I divide that by negative 6, so I'll have negative 1/6 is equal to y plus 3, and I subtract 3, so it's negative 3 and 1/6. So right about there, symmetry puts 1 on the other side. And when I use 7, 7 minus 9 is 2. 2 squared, sorry, negative 2. Negative 2 squared is 4. And 4 divided by negative 6 would be negative 2/3 is equal to y plus 3. So y would be negative 3 and 2/3. So right about there, I have a point here, and there's my parabola. Okay, so I had to complete the square to put it in standard form. And after that, I just went through the process of graphing. So a little review of graphing. If you take a look at this, I could again do the b squared minus 4ac, but I really want to encourage you to take a look at these things and think about them. So what I want to do is I want to put my x's together. So I'll have 9x squared plus 18x. And I want to put my y's together, so I'll have plus 4y squared plus 8y. And I want to put the constant over to the other side, equals 41. Okay, and now the key here is you see I have a plus there. All right, that means if I have a plus between the x's and the y's, this is either a circle or an ellipse. So I've eliminated parabola and I've eliminated hyperbola. And I haven't done the discriminant. If I factor a 9 out of this, I'll have 9 times x squared plus 2x. And I factor a 4 out of that, I'll have 4 times y squared plus 2y equals 41. And you see, my coefficients are not the same number, so now I know this is an ellipse. Okay, if they'd been the same number, it would be a circle, but this is an ellipse. So if I want to put this in standard form, I've got to complete the square 2 times. So I'm going to take 2, divide it by 2, and square it. So 2 divided by 2 is 1, 1 squared is 1. So over here I'll have 9 times x squared plus 2x plus 1. And then I'm going to do the same over here, and again it's 2, so I'll have y squared plus 2y plus 1 equals 41. But now I have to add to the other side, and you see, you might think I added 1 and I added 1, so I need to add 2. But remember, the coefficients change that. When I'm putting a 1 here, I have to multiply it by 9. So I have to add 9. And with a coefficient of 4 here, when I put in 1, I have to add 4. So this becomes 54. And over here, I'll have 9 times x plus 1 squared plus 4 times y plus 1 squared equals 54. Now, the whole thing has to equal 1, so I'm going to divide everything by 54. Okay, and 9 goes into 54 6 times. So I'll have x plus 1 squared over 6 plus 4 goes into 54. It doesn't perfectly go into 54, right? But I can factor out a 2, right? So half of 54 is 27, so this will be 27 halves x plus 1 squared, and it equals 1. So now you can see that 27 halves, right? That's 13 and a half. That's going to be more than the 6. My numbers are going to be weird. So I'm going to have the square root of 13 and a half. That's going to be a strange number. I'm going to have a center at negative 1, negative 1. So negative 1, negative 1, that's my center. And I'm going to want to move up the square root of 13 and a half. So that's going to be between 3 and 4, right? 1, 2, 3, So I'm just going to estimate that in 1, 2, 3, about there. And right and left, I'm going to do the square root of 6. So that's between 1, 2, and 3. So 2.5. 1, 2.5. Here's my ellipse. Then I'd want to find my focus. Right? I know that c squared is equal to 27 halves minus 6, which would be 12 halves. So 27 minus 12 is 15 halves, or 7.5. So my foci would be on this axis, so I know that my x-coordinate is still going to be -1. And it's going to be my original amount, right, which would be the square root of 13.5 plus or minus the square root of 7.5. Okay. So a little awkward numbers. You could use a calculator, get decimals if you like. But what's important is understanding that I had to complete the square twice in order to do this. And when I add into an item that is in parentheses with a coefficient, I'm not adding 1, I'm adding the 1 times the coefficient, or whatever number I'm adding here has to be multiplied times the coefficient. Okay, so here's another problem to work with. We've got this idea that we're going to record images of a steel ball rolling past the magnet, and the magnet is going to bend the path of the ball. It's going to take a certain shape, and they've got this equation that models it. So what I want to do is I want to put this equation into some form of standard form. Now, to answer what is the shape of the path, I could do b squared minus 4ac. I got to be honest with you, I never do that. If I just order things up the way I want to do it, 16x squared minus 96x minus 9y squared plus 36y equals 36. So I'm just starting into the path of doing the equation in standard form. These are the first steps. I'm making these clusters. And you can see I have a minus sign here. Well, there's only one type of conic section that has a minus between the x's and the y's. This is a hyperbola. Okay, so you can see it's going to follow this path of a hyperbola. There would be a matching one over here. We're really only working with this branch of the hyperbola. Okay, so if I want to go ahead and start putting this into the right form, 16 times x squared minus 6x minus 9 times y squared plus 4. Oh, but I'm putting in parentheses after a minus sign. That means this sign has to change. Minus 4y equals 36. Okay, now I'm going to take 6 divided by 2 and square it. 6 divided by 2 is 3. 3 squared is 9. So I'll have 16 times x squared minus 6x plus 3 squared. And over here, I'll have 36 plus 16 times 9. Okay, because I added 9 here, but it's being multiplied times the 16. Minus 9 times y squared minus 4y, and I take the 4 divided by 2, which is 2, and I square it, and I add that in, 2 squared, which is 4. So this is going to be minus, because I added it after the minus sign, 9 times 4. Okay, so when I work with this, I'll have 16 times x plus 3 squared minus 9 times y minus 2 squared equals 16 times 9 is 90, and 54, this is 144, and 9 times 4 is 36. So the 36 and the 36 are going to cancel each other out. This is going to be 144. And I'll divide everything by 144. So I'll have x plus 3 squared over 9 minus y minus 2 squared over 16 equals 1. So this is my equation. Right? And then if I wanted to graph the equation of the path, I would go ahead and graph this hyperbola. We've already gone through how you graph a hyperbola. I know that my center, though, is at, let's do a really quick version of this. My center is at negative 3, 2. So 1, 2, 3, 1, 2. Here's my center. Because h and k are negative 3 and 2. This is going to lead me to my vertices. I'm going to move 3 in the x direction. So 1, 2, 3. That's a vertex. And 1, 2, 3. That's another vertex. Okay, so my vertices are going to be at 0, 2, and also at 6, 2. All right, and then if I want to go ahead and put in, these guys are going to move 4, 1, 2, 3, 4 up here, and 1, 2, 3, 4 down here. And I can make this box, right? The box is very helpful. I draw through this way, and my graph looks like that, right? There's another one over here, but obviously this is the one we're going to be using. Okay, so that's how I would work with this. Do some practice classifying the conics and getting them graphed. Do 42 and 44. Come on back, and we'll finish out the lecture.